In this video, we will build a microservice in Python using the fastapi framework. It's a really good framework, and in terms of performance, it's one of the best frameworks out there. I strongly recommend using it, and in this video, I will show you how. I will only show you a very basic setup, so if you want to have a more complex one, please feel free to go through the documentation. It's really good. I recommend you do it yourself as an exercise kind of. However, we will focus here on how to actually put what you find in the documentation into context. So what we will do is we will write the endpoint, and we will build a little folder structure so that your app has a proper architecture that will later on help you to design proper services. And also we will build the container files that you will need if you want to deploy this as a standalone app on, say, Kubernetes or whatever tool you're reusing. Enjoy. We are going to be using VS Code for this tutorial. If you don't already have it installed on Debian or Ubuntu, you can do that via sudo snap install -- classic code, I believe is the name. It's already installed on my machine, that's why nothing happens. And then you can start it via code. Floop, here we go. And then you can pick a dark theme because the light theme attracts bugs. And then we can start. Done. So now we are going to open a folder, which in my case is going to be documents, and here we are going to create a new folder. Let's call it fastapi _tut, and then we're going to pick this folder. So yes, I do trust the author because that's myself. And then we're going to create the following structure. So first you need one directory that is called src for source, and then you need a second one called tests, where all the tests will go. So next we're going to write our requirements file, requirements.txt, and we're going to be using fastapi, pydantic, uvicorn. Uvicorn is going to be the actual server implementation that is going to host our service as a web service. Uvicorn is the version using the UV loop, which makes asynchronous Python very effective. But more on that later. I think for now this should be good, so hit Control save to save the file, or go to the settings and set up that VS Code always saves your files. Otherwise you're going to be very confused when you're trying to run your code and this is not written into the file actually. So to implement our app, we're going to need a couple of things. So first we're going to write a main.py file. This is where we're going to define the app. So what we're going to do is from fastapi import fastapi, and then we're going to define the app. App is equal to fastapi. This is going to be the main app that will compose our service. Then we're going to create a folder that we call, I usually call it service or server. Doesn't really matter, but this is where the actual implementation of your service will go. Don't call it app, because if you call it app, it's going to clash with this app here. So now in the server, we're going to write our first endpoints. So in order to do that, we're going to create a new Python file with the name, let's think of something good. Usually I call it just CRUD for create, read, edit, destroy, delete, whatever you want to say for D. Sometimes it's good to call it endpoint, just so people know that this is going to be the endpoint implementation. But CRUDs should be sufficient to explain that. So in here, we are going to import a router. So from fastapi import API router. Then we're going to construct the router simply by doing, let's call them CRUD router version 1. This is kind of breaking with the idea of REST a tiny bit, but I think it's very good to actually version your routers, and you will see how this works out later. So API router, oops, API router, and then you can put the fields in here. We are going to use a prefix that is going to be / whatever you want to call your resource. So resource depends on what kind of server you're implementing, right? So let's call this resource, and you can put whatever you want here later. And then you can also put tags. Doesn't really matter what you put here. You can write resources. Okay, now we're going to implement the first endpoint. We're going to implement HTTP GET. So in order to do this, you just use the router and you add a GET endpoint. This GET endpoint simply gets the name. So this prefix will be put in front of this, and then you can get at this endpoint. So let's call this resource again. One very important thing in implementing these type of endpoints is that if you are following a REST schema or REST in general, don't call these things get resource, but just by the resource name, because it's going to be confusing for people who are a bit more senior. Anyway, and then we can give it a description. Let's say our first get endpoint. And now we actually have to implement it. In fastapi, everything is implemented via asynchronous functions. So just put async def get resource. If you now want a path parameter, this is very easily done by just doing something like this. Name, and then you can define it here as one of the function parameters, name string return you gave me name, and this must be a function, of course. You can look into the fastapi documentation for how to implement the other endpoints. It's very well documented and it's very easy. That's why we won't go into more detail here. Now, in order to actually make this endpoint active, because the app doesn't know about it, we have to first import the router. So from server, what did we call it? CRUDs import CRUD router, and then we include the router in the app. Include router name, and then you can give it a prefix. This prefix is going to be the routing prefix. So we put v1 here. So this is going to be reachable under /v1 /resource/resource, and then name. Okay, So this should already work. Always remember to press Command S to save your stuff. Now we're going to write a little file to deploy the stuff. So we do run local.sh. The usual stuff, bin bash, and I've had fingered. And we're going to be using UVcorn as the VSG app that actually runs our app that we just wrote as a HTTP service. So we're going to be using UVcorn. UVcorn is an implementation of Unicorn. UVcorn, however, uses the UV loop, which is more efficient if you want to do async Python. And this is exactly what fastapi does. That's why we use UVcorn. So we need to do main app. So we need to tell it what the file is called and what the app is called. So file is called main, app is called app, and then we give it a directory. App minus dir is dot source, dot slash source, not a hidden directory. As host we use, let's say, 000, and we use the port 8080. Always use ports above 8000. Yeah, if you want to use, actually for Kubernetes it doesn't matter. You just need to know that some port ranges are reserved. So everything below 8000 is reserved for the system, and Kubernetes services usually reserve everything between 32,000 and something above that. So 8080 is a good choice. So save again. Then we go to the shell. First thing we need to do is actually install the requirements. So we have to set up a virtual environment, which we do with pip3 -m venv. Actually Python 3, sorry. And rename it venv. Then we activate it, source, or actually I still have one active here, but we're going to do this anyway. Venv bin activate, and then we're going to install the requirements. So pip3 install -r requirements. I already installed them, so it wouldn't take too long. And now we're going to run the local service. Local, why doesn't it autocomplete? So, run local. Description, unexpected, CRUD's description. 1 second, I need to think. Why doesn't this work? Because description is spelled with a P. Too easy, don't forget to save. And now it's running. We can now access this fastapi app in our local browser. So we're going to start Firefox. Just move it to the window here, and then you can do localhost, so this machine, and then you have a look at port 8080. And we get a not found because we did not implement a \endpoint. But if we now go to docs, this is something we did not implement. However, this is where fastapi comes in super handy, because fastapi automatically generates this OpenRP Swagger documentation for you. So you can automatically generate this nice resource thingy here. the description with a P that we just put in here is going to end up in here, and we can easily test it. So we can put in name, let's say try out Peter, execute, and then you get the response body here. So this is how you deploy a very simple fast API app. Obviously, you can also reach that endpoint by going to the endpoint directly. So 8080, what do we call it? V1 resource, and then you pass Peter, and it gives you gave me Peter. Now we're going to improve this a tiny bit, just to get you used to the concept of abstraction. So in this server directory, we're going to implement a new file. We're going to call it server or whatever, app service.py. So I suggest that you use something of a modified MVC pattern. MVC stands for Model View Controller. There are many reasons to do it, and there are many reasons not to do it. But the general idea is that you separate endpoints and implementation, and also that you, when you implement the actual implementation, that you separate stuff that does things from stuff that is just a controller that just controls things, and also actual stuff that's being worked on. So you want to separate these completely from each other. And what I usually do is I implement a controller. It's like the app controller. And in here, we're going to write a simple class. Let's call it app controller. With the init function, init self pass, not going to do anything. And here we define the get resource function. Self name return. So here's where you're going to put the implementation. So you're going to rip this stuff here out, put it here, and then here we're just going to import this class. So from app controller import app controller SAC, and then here you can do return ac.get resource name. So the reason to do this is, actually this must be not app controller but server.app controller. Server app controller. The reason to do this is you never want implementation details right at the spot where you implement the endpoint. That is because if you need to change this or you want to test something else, it's going to be harder. If you have it here, you can simply make another resource function, let's say get resource 2, or something more creative than that maybe. But you don't have to completely delete the code here. You could have a different function here, or just change the function here. That's going to make your life much easier later on if you want to change things. That's why here you always just refer to some kind of controller that then implements the actual app. To be very precise, actually in the controller you don't want to implement any complex logic, you would have another file called service that you import in the controller, and then the controller uses this service to do, for example, this here. But this only makes sense once your app becomes complicated enough to actually do this. I'm just showing you this here just to give you some ideas on how to structure your code. But it's in the end really, really use case specific and really also depends on your style. We're now going to improve this a bit. You see, if you wanted to change this, you would have to touch the endpoint file, and this is generally a bad idea because you want this to be a bit easier maintainable. So one rule for myself that I came up with and that I suggest you also follow: never put actual implementation into the endpoint functions. So it's always good to hide the implementation elsewhere, for example, in a new file. I generally have something called app controller. This is a controller that controls the app, so to speak. This is somewhat derived from the MVC idea, the model view controller idea, that you separate controllers and implementation logic, and also that you implement the model, that you separate off the models that you're working on. In this case, we're just using a controller. Once you have apps that do more complicated stuff, I suggest that you also split controllers and services, so that controllers only do calling functions on other services, and the services themselves, so calculator service, for example, that does like a complex calculation, and the controller just controls this by pushing in values. This way you end up with something that is flexible enough to change and maintain your code easily. Anyway, so now we're going to just implement a controller that's going to be a very simple class app controller. Don't need to inherit. Do we even need a constructor? Actually, I don't think so, but whatever. Self pass keyword fat fingers get resource. So this is the function that we want to abstract away. Self, and it needs the name, and then we're just going to put this implementation in here. This should work. And then we're going to create an instance of this controller here. So we're going to be app controller is equal to app controller. When you build apps like this, you have to be very, very mindful of state. If you have a stateful application that, for example, saves the name or something, then in that case, always use a database. Because if you go to this endpoint resource here and you put something in, this is one instance of the app, but you might have multiple workers that all deploy the same version of the app. So what happens inside the server might be that there's multiple workers and they will all have a different state. So the only way to synchronize this state is to externalize it into a database. So when you do stuff like defining objects like this, be very, very careful, because later on when you want to scale this app, this can be a really thorn in your side, so to speak. So be careful with doing stuff like this. Anyway, from server dot app controller import app controller as a C, and then you can do AC read, no. Something like this. So if you now have to change what this get resource function does, you don't have to touch the endpoints, you can all do here. Let's check if it still works. And it does. Let's go to this thing again, reload, try it out. Name, execute, and you gave me name. Yeah, because I wanted to give something more Peter. So this still works. Now we will have a look on how to test these things. You need two things to be installed. You need PyTest, which is the framework we're going to use for testing. PyTest and HTTPX. This is something that fastapi uses in the test client. So these two, then we do the usual pip3, oops, pip3 install -r requirements. Of course, I already installed everything. Then next up, we're going to create a file called test main. Doesn't matter what you call these files, PyTest will automatically collect them. So in order to test fastapi, fastapi provides you with a test client, so you can do from fastapi.test client import test client, and of course this IDE is not properly set up, but anyway, so we're going to write a client, but now you will see a small problem. The test client has a dependency on the app. So this is a problem because I pulled the test folder out of the source folder. The reason for that is later when we build our Docker file, we don't need the tests in the container. And in order to keep the container as small as possible, I pulled them out. Even though if you really want a small container, the operating system you use for the container has the most impact. Anyway, your app might be large, so that's why I'm showing this here. To deal with this, we have to do a small hack. We have to put the source directory on the Python path of the system. So the way we're going to do this is you can either do it in one line with a colon separating things, or you just do it in a new line. Yeah, so what we're going to do is we're going to add path.append. So on the sys path where Python is looking for Python modules, we're going to append os.path.dearname of os path real path of this file. So __ file is this file here called test.main. And dear name of that is going to be the fastapi tutorial folder here. And then we're going to append this to the path. But we're not done yet. We need to actually, because the path of this file is actually the tests directory. So we have to go back one directory and add the source folder. Now, oops, and we don't need path here. This is also nonsense. Now we can do from source.main import app. Save this. Dearname real path file one back source. So this should work. Let's see if this works. So the way you run PyTest is just by typing PyTest, and then you give it the path to where you have the tests. One error, no module named source. So let's have a look. I think we just... Did I mess anything up? A good exercise in debugging. Could it just be main? Yes. Okay, so now we are going to implement the test. So the point is I put source on the path, so it's actually looking in source. So source cannot be the module name. So the module here is main, so this Python file. And here it's going to take the app out. Yeah, so let's define our first test. Test CRUD. Or let's just test get. Yeah, I'm just going to give you an example of how you could do this. Example expected is equal to, let's say, John. And then we're going to use the client. Client.get. And we want to keep the response. Response is client.get. What did we name the thing? v1 resource. And then here we have the path parameter, and here we're going to put expected. And then we do simple assertion testing. Response.json. And we are checking if expected is expected in response.json, because what this returns is going to be a string, so we're just checking if John, the expected string as we put it in here, is in the response. Okay, let's see if this works. PyTest, and it works. One note on PyTest: if you want to see print statements print out, you have to pass -s. So in case you're debugging your tests or something. And yeah, so as you see, one test passed in a relatively short amount of time, and one dot actually means one test was run. So this way you can test all of your endpoints. Another way of doing this would be using Python's request package. So what you could do is response is equal to requests.get, and then you put the path, so this guy here. But in that case, you would have to add the request package here. Lastly, we're going to containerize our application, and we're going to build a Docker file for that. So we're going to create a new file called Docker file. In this Docker file, there's a series of commands that tell Docker how to build the container. And the order in which you execute them actually matters for the performance that Docker later on has. But first of all, we're going to build it. So we are going to use a base image from docker.io/Python 3.11. You can leave out the registry where you are going to pull this from, which is this first part, and just write from Python 3.11. And this one is the base image that's going to be used. There's hundreds of them. I just randomly pick this one. There's Alpine, they are very small images. Yeah, depends on your requirements what kind of choice you're making there. In my experience, it's very important to also mention which registry you're going to use, because we are going to use podman, and podman tries to do smart things in the background that are not so smart if you don't put the registry here. So don't forget to put the registry here. then we're going to expose port 8080. That just means that a port within the container is going to be exposed to the outside, so that we can map ports of this virtual machine that I'm running here to an application inside the container. Next up, we're going to define a work directory, let's say code. So in your Linux operating system that's behind this thing here, Docker is going to create a folder called /code, so in the root directory, and that's where we're going to put all our stuff. So then we're going to do copy dot requirements dot text txt, and we're going to copy that to code requirements. You could also do a pip freeze and pipe the output into a requirements.prod file, for example, and then use that here. For our use case, just to demonstrate to you, this is enough, I think. Then we're going to copy this run local script, run local.sh. Now we're going to run a command, pip install -no -cache -dir, because we don't need a pip cache dir in the container, because we're just going to install one -upgrade -r the requirements file. Also, I don't think you need the upgrade. We're going to put it anyways. Some people even upgrade pip first, so you could run before you do that. You can do like a pip upgrade, upgrade or update. I'm not entirely sure. It's not necessary. Pip might complain if you build the container, but for this use case here, it doesn't really matter. And then the last thing we do is we're going to copy the code from the source directory into /code/source. And this here is the entire reason why we pulled out the tests from the source directory, because this keeps our Docker file, the resulting container, as slim as possible. And then we're going to do an entry point, and here we are using bash to run this script here. So /run local.sh. So dot here refers to this working directory here. There's many ways of building these files, so this is not necessarily the best way, but it's one working way. And yeah, this is the way I usually work. Okay, one more note. Everything you do here, every line, creates a cached layer in Docker. That means you want to order them in the order of probability of you touching something. So if we touch something in source, then this layer has to be rebuilt. So if you rebuild the container, all this stuff can be cached, can be used from the cache, and only this layer here has to be built on top. So in order to get maximum performance when you build these files, you want to have the first lines be the stuff that you touch the least. Okay, so let's see if this works. Of course, I already tested this. However, we're going to build the container. You build a container with podman build -t for target. Let's call it fastapi. You can also specify a directory, an image registry where you want to push this. So in our case, this would be localhost / blah blah blah, and you can also put a tag, something like latest or version 1 or something. But we're now just using fastapi, and dot is the directory that we want to build. Hamster wheel is spinning. By the way, if you don't have podman installed, just do sudo apt update and apt install podman sudo. This would install podman on a Debian style system. Now we have built the container. So in order to, let me make this larger actually. I hope this is large enough. A bit annoying to bring into the right spot. So sorry for that. And also we don't need this. So yeah, in order to build, you do podman build -t, and then the target name and the directory where the Docker file is located. And then in order to run it, you do podman run, or did we expose a pod? Yeah. Run -p 8080 8090. You can also, here you can use whatever you want. 8080 is the inner port, so the port that is exposed within the container to podman, and podman now maps 8090 on the local machine, so this virtual machine that I'm running here, to that. What that means we will see in a minute. And then you can just specify fastapi is the thing that we wanted to run. So now let's see if I got the order of these right, because I always mix them up. Okay, let's have a look. Localhost 8090. And we are unable to connect. That means I think I messed up the order here. For some reason, killing the app here doesn't work. So what I do is I just start a new shell with podman ps. You can see all the containers that are running. So you see it automatically translated when I build the container, my fastapi to localhost /. So this is the registry, container name, and the latest, and the tag, which in this case was latest. The port mapping should be correct. That's why I'm a bit confused. And inside it's running on 8080. So outside should be findable on localhost 8090, but why isn't it? 8080 doesn't work. 8090. Anyway, so in order to kill a container, you can do podman kill this, and now if we have a look, podman ps, it's gone. You can also do container kill -a, that kills all container. And with rm, you remove the containers that you built. You see, I built a lot of garbage already, so there it goes. So we are going to rebuild this thing. Let me see, did we save this? Run local runs on 8080. We are exposing 8080. Should work. Nah. Let's make sure it's not the port. So now we're mapping the internal to the external port 8080. So if we go here, this works on 8080. So anyway, so this is the app within the container. So just to finish my thought, I want to see if I just used the wrong side. Maybe this way. 8090. So okay. So you see the syntax is the other way. So this is the port on the local machine. So this virtual machine, and the second one is the inner port. So it's outer and inner port. Okay, so yeah, that concludes the tutorial for today. I hope you learned something, and yeah, see you next time.